Hello guys, JM here, and welcome to a physics video where my group and I will discuss circuits. So, if you came here expecting anything else, then you came to the wrong video. But you're free to stay anyway. Anyway, let's get to the video. Alright, so let's begin with the series circuit. Here is an example of a series circuit. As you can see, they are connected in a way that lets the current through only one route. That simply means that they share the current. Some other things to remember about series circuits are: the equivalent resistance of all resistors is equal to the sum of the individual resistances. And the voltage of the battery is equal to the sum of the individual voltages. So, let's take a look at our experiment. So, as you can see here, this is our experiment for series circuits. As the electrical plug is put, you can see that the light bulbs light up with the same amount of energy. This confirms that they receive the same amount of current. There, as you can see there. Now, we will have a different demonstration. As you can see, whenever he takes off the light bulbs, all of them lose their light. That is because they only receive one current, and thus, whenever one is removed, they all lose their current. Alright, so let's get to the parallel circuits. But first of all, here's a schematic diagram for parallel circuits. So, a parallel circuit has certain characteristics and rules that are different from series circuits. First of all, a parallel circuit has two or more paths for current to flow through, rather than a series circuit with only one. Number two, voltage is the same across each component of the parallel circuit. So whatever the voltage of the battery is the voltage of each and every one of the resistors. The sum of the currents through each path is equal to the total current that flows from the source. And the total resistance of the entire circuit is always less than the individual resistances of the resistors. So let's take a look at our experiment. So, as you can see here, this is our experiment for parallel circuits. Here you can see 4 light bulbs connected in parallel, shining brightly. Now, as we remove one bulb at a time, you can see that the other bulbs light up tremendously. And it seems to be growing stronger despite the constant voltage given. So as you can see, as 3 light bulbs are removed with 1 light bulb remaining, there is still a path for the current to move through, therefore it's still lighting up. Lastly, let's go with the series parallel circuit. But first, once more, here's a schematic diagram of the series parallel circuit. Now, as you can see, the series parallel circuit implements both the series and parallel circuit rules, as it involves one pair of resistors in series connected in parallel to another pair of resistors in series. Now, you're probably wondering, what in the world am I saying? Am I crazy? Probably. It'll be easier to explain once we get to the experiment. Now, if you look here, this is the series parallel circuit. Now you can see that 2 of the light bulbs are connected in series. Now look what happens when they remove one of the light bulbs. As you can see, only light on both of the light bulbs is lost. That is how the series parallel works. And that's that. If you reached the end of the video, thank you so much for watching Physics with Nerds. We do hope you learned something about circuits from the video, and if you liked the video, give us a thumbs up. It'll help really well with our self-esteem. Again, thanks for watching.